So today, we are going to be solving for a system of equations when it comes to parallel lines. So we're given two equations, and the question asks, in the system of equations, P is a constant. If the system has no solution, what is the value of P? So we know that there's a system of equations and there is no solution. What does it mean if a system of equation has no solution? When a system of equation has no solution, it pretty much means that the lines never intersect. Why is that? A solution refers to the point when two lines intersect. If there is no solution, then the two lines never intersect. When does this happen? When a system of equation has no solution and the lines never meet, this happens in the case of parallel lines. Why is that? The reason this happens is because parallel lines have the same slope, which means that two lines that are parallel are pretty much the same lines. They have the same slope. They just have a different y-intercept. So they start from different places, but they have the same slope. Since they have the same slope, they never intersect and ultimately have no solution. So in order to solve for that particular system of equation that we're given in the question, we will solve one equation at a time. So we first work with the first equation, which is 3 over 2y minus 1/4 x is equal to 2 over 3 minus 3 over 2y. We will transform this equation into y is equal to mx plus b format. The y is equal to mx plus b format is also known as the slope-intercept. And the reason why we're using the slope-intercept is because we know that those two lines are parallel. And two parallel lines always have the same slope. And in the slope-intercept form, the m stands for the slope. So if we understand the slope of this line, if we can find out the slope of this line, then we automatically know then that for the other equation, it's also going to have the same slope. So in order to solve for this equation, to turn it into y is equal to mx plus b format, we start off by trying to isolate the y to be on one side. So we add 3 over 2y to both sides, and we get 3y is equal to 1/4 x is equal to 2 over 3. And then we divide both sides by 3 to get the y isolated, and we get y is equal to 1 over 12x plus 2 over 9. And again, y is equal to mx plus b format, m is equal to the slope. So in this case, y is equal to 1 over 12x plus 2 over 9. So 1 over 12 is the slope. So we know that the slope for our two lines is 1 over 12. We know that the slope for this line is 1 over 12, and um, since we know that they're parallel lines, the other line is also going to have the same slope. So then we work with the second equation. We're also going to try to put it in the same format, y is equal to mx plus b format. In order to do that, we do the same thing. We try to get y isolated on the same side, but remember, in this case, we also have the p constant, which we're trying to find the value of. So we subtract 9 over 2 from both sides, and then we have 1 over 2x minus 6 over 3, which is pretty much 6 over 2, which is equal to 3, is equal to py. So we have 1 over 2x minus 3 is equal to py. So since we have the p constant and we can't get rid of it yet, we pretty much have the equation equal to py is equal to 1/2 x minus 3. So we have our two equations. And now remember, the interesting thing here is that when two lines are parallel and they have no solution, their y-intercepts don't matter, so we can get rid of it. So what we're going to do is that we're pretty much going to set the two equations equal to each other in order to find the value of p, since we know that they never intersect, and their y-intercepts don't matter. So in order to do that, we are going to have to get rid of p from one of the equations so that there's only y on one side. So we have the equation, the second equation that we figured out the solution to, py is equal to 1/2 x minus 3. So we're going to divide both sides by p so that we only have y on one side. So you have y is equal to 1/2 x over p. And remember the other equation that helped us figure out the slope, which is y is equal to 1 over 12x plus 2 over 9. And the first equation, 1 over 2x minus 3, had the y-intercept of -3, and the other line, y is equal to 1/2, y is equal to 1 over 12x plus 2 over 9 had the y-intercept of 2 over 9. But remember, the y-intercept does not matter here because they're parallel lines. So we're going to get rid of both of the y-intercepts. So we're left with the equation y is equal to 1 half x over p and y is equal to 1 over 12x. So now, in order to find out the value of p, since both of the equations have y, we're just going to set it equal to each other and figure out the value of p. So we have 1 over 2 over p is equal to 1 over 12. Again, the x here does not matter. And in order to solve for it, we're going to multiply both sides by p, and then we will pretty much have 1 over 12p is equal to 1 half. And then we will multiply both sides by 12, and then we'll get the value of p is equal to 6. So what does this mean? This means that, going back to the first slide, in this system of equation, we need to ensure that they're parallel lines. We have to make sure that they're parallel lines because the only way in which they would have no solution is if they're parallel lines. And these two equations will be parallel lines if the value of p is 6, as we found out. Now, let's come up with a chant to remember the fact that in parallel lines, they don't intercept and they don't have a solution. How can we do that? Let's come up with a chant. So the chant that I came up with is same slope, different spot, no solution. That's the plot. What was it again? Same slope because parallel lines have the same slope. Different spot because they have different y-intercepts. No solutions, we know, because parallel lines don't intersect, so there's no solution. That's the plot. So that's how we know the whole story. So the whole chant goes like, same slope, different spot, no solution. That's the plot. Same slope, different spot, no solution. That's the plot. Same slope, different spot, no solution. That's the plot. And that's the lesson for the day.